Welcome to the Explainer. Today we're doing more than just learning a few Linux commands. We're actually building a mental toolkit, the kind that takes you from frantically searching man pages to confidently and quickly fixing real-world server problems when the pressure's on. So what's the real difference? It's not about memorizing hundreds of commands. Not at all. It's about instinct. It's knowing that when a service goes down, your first thought is, let me check the logs with journalctl, not, uh-oh, let's just reboot it and see what happens. It's about having that go-to set of tools you can rely on for any situation. And that's exactly what we're building today. But don't think of this as just a Swiss Army knife with a bunch of random tools. No, think of it as a complete, integrated system where these commands work together in really powerful ways, letting you solve the unique problems you run into every single day. So here's how we're going to break this down. We're going to build our toolkit in 4 layers. First, we'll cover the essentials you'll be using day in, day out. Then we'll jump into those high-stakes troubleshooting scenarios. After that, we'll get into the super important topic of access and security. And finally, we'll top it off by showing you how to automate your work so you can stop fighting fires and start building better systems. Okay, let's dive right into that first layer, your everyday command toolkit. These are the commands you're going to reach for over and over again to see what your systems are doing, manage your services, and just get your work done. These right here are the absolute workhorses. You've got tail F, which lets you watch a log file scroll by in real time. It's like an EKG for your application. Then there's grep, your secret weapon for finding that one needle in a haystack error message. And of course, systemctl, which gives you complete control over starting, stopping, and checking on any service. These are the bedrock of almost every diagnostic task you'll ever do. Okay, let's get practical. Take a look at this command. This is an absolute lifesaver for a super common problem, old log files just eating up all of your disk space. With this one simple find command, we can hunt down every single log file that's older than a week and get ready to do something about it. And this right here is where the command line just shines. Each of these little flags is like a precision filter. We're telling the system exactly what to do. Hey, go into the var/log directory. I only want to see files, and only show me the ones that haven't been touched in over 7 days. Getting good at using these flags is how you turn a simple tool into a surgical instrument for automation. So, knowing your day-to-day tools is one thing, but now we move on to the real test, right? Troubleshooting under pressure. This is what you need when the alerts start blazing and everyone's looking to you for the fix. Ah, the classic. Your heart just drops a little, doesn't it? The website's down, the clock is ticking. The absolute worst thing you can do is just panic and start rebooting things randomly. No, you need a calm, step-by-step process that lets you rule things out one layer at a time. So we always start from the outside and work our way in. Step 1. Is it actually down for the whole world, or is it just your local network acting up? Step 2. Is DNS even pointing to the right server? And step 3. Is there a firewall or a cloud security group just silently dropping all the traffic? Answering just these 3 questions can rule out a huge chunk of potential issues before you even log into a server. All right, so you've confirmed the outside world can reach the server. Now it's time to pop the hood. Is the web server, like NGINX or Apache, even running? If it is, what are the logs telling you? 9 times out of 10, a quick look in /var log will point you right to the problem. And if the logs look clean, it's time to check the server's vital signs. Is it out of disk space? Is the CPU maxed out? And this slide shows 2 of those classic emergencies perfectly. On the one hand, you've got high CPU usage, making everything grind to a halt. Your go-to tool there is top, or maybe the friendlier htop, to find the process that's hogging everything. On the other hand, you've got a full var directory, which can stop services dead in their tracks. For that, you use du to find what's eating up all the space. The key skill is being able to quickly tell which kind of problem you're facing so you can grab the right tool for the job. Okay, let's talk about a really critical part of your toolkit, especially in the cloud, managing secure access. See, back in the day, if you got locked out, you could just wheel a cart up to the server rack and plug in a keyboard. You can't do that with a cloud instance. Everything is remote, which means you have to be rock solid on how you get in and who you let in. I want you to let this one really sink in. That private key file you use for SSH, your PEM file, that is a one-time download. If you lose it, it is gone forever. There's no forgot my password link, it's just gone, and you're locked out. But, and this is a huge but, all is not lost. This is not a catastrophic failure.
There is a well-known rescue procedure. It's kind of like performing a key transplant that lets you get back in. And honestly, every single person working in the cloud needs to know how to do this. So here is the play-by-play. You stop your locked-out server, and you literally detach its main hard drive. Then, you attach that same drive to a temporary rescue server that you can access. You log into that rescue server, find the drive, and edit the authorized_keys file to add your new public key. Then you just move the drive back to the original server and turn it on. It feels like performing major surgery on your server, but believe me, it is an absolute lifesaver. All right, for the final layer of our toolkit, we make a really important shift. We go from being a firefighter to being an architect. See, a firefighter just reacts to problems. An architect designs systems to prevent those problems from ever happening in the first place. This is all about making your systems work for you. Hey, remember that find command we used earlier to track down old logs? Let's put that thing on autopilot. Instead of waiting for that 3 a.m. alert that your disk is full, we can just script an automatic policy. After 7 days, logs get compressed. After 30, they get deleted. You set it up once with a cron job, and you literally never have to worry about it again. That's smart. And we can apply that same proactive thinking to our services. Imagine a simple little script that's like a digital watchdog. It just keeps a list of your most important services, NGINX, Docker, whatever, and it checks on them every few minutes. If it finds one has crashed, it'll try to restart it automatically. It's a simple, powerful way to improve your uptime without you having to lift a finger. And this is why all of this matters. When you master automation, it completely changes your job. You spend way less time in that stressful, reactive firefighting mode. That frees up your brain to focus on the big stuff, proactive automation and strategic improvements. That's the work that actually makes your systems more reliable and resilient for the long haul. So there you have it. That's our explainer on building a powerful Linux toolkit. But really, this is just the beginning. The true magic happens when you start combining these tools in new ways to solve your own unique challenges. The tools are in your hands now. The only question is, what problem are you going to solve first?